Hello everyone, we're Team GMAT 770. We are focusing on teaching and training GMAT test takers all over the world, especially in North America and in Asia. Our goal is to help GMAT test takers to pass GMAT tests before they apply for graduate schools all over the world. The test score of each of our team members is about 750, and the co-founders of our team got GMAT test score 770, so that's the reasons why we call this name. I'm the math teacher, Corinne, of our team, and I hope that from these lessons about math, you will easily pass quantitative parts in GMAT test. So are you ready? Let's get started. Okay, according to the last lecture, Inequalities Part 1, we have learned some basic rules of inequalities. In this lecture, Inequalities Part 2, we will move on to some more difficult types of questions about inequalities you will face in GMAT test. Today we will focus on 4 different types of questions. The first one is inequalities with absolute values. And second, with square numbers. And third, with square roots. And last one, I think the most difficult one, is inequalities with exponential functions. So let's move on to the first one, inequalities with absolute values. Okay, actually you have different kinds of method to solve these kinds of questions, inequalities with absolute values. The first method is you can just take off the absolute value mark directly. But please remember, if you want to use this kind of method, you have to discuss whether the part within the absolute value mark positive or negative. So let's use a simple example to explain how it works. So for example, if you have the absolute value of x minus 3 is less than 7. So what's the range of value of x? If you wanted to use this method to take off the absolute value mark directly, you have to discuss whether x minus 3 is positive or negative. For example, if the part within the absolute value mark is no less than 0, which means that x minus 3 is no less than 0, x is no less than 3, you can just take off the absolute value mark directly. So you have x minus 3 is less than 7, so x is less than 10. And then you combine these two ranges together to get the range of value of x when x is no less than 3. So you have x is less than 10 and is no less than 3. And what about if the part within the absolute value mark negative, which means that if x minus 3 is less than 0, x is less than 3. So what's the range of value of x? So if the part within the absolute value mark is negative, when you take off the absolute value mark, you have to change the marks here. So you will have 3 minus x is less than 7, and x is greater than negative 4. And then you combine these two ranges together to get the range of value of x when x is less than 3. So you will have x is greater than negative 4 and less than 3. And then you just combine these two ranges together to get the range of value of x to these inequalities. So you will have x is greater than negative 4 and it's less than 10. So this is the answer to this question. So please remember, if you want to take off the absolute value mark directly, you have to discuss whether the part within the absolute value mark positive or negative. The second method to solve these kinds of questions is to square both sides of the inequalities. But please remember that you can only use this kinds of method when you have absolute values on both sides. For example, if you have absolute value of x minus 3 is less than the absolute value of x plus 3, what is the range of the value of x? According to method 2, you can just square both sides of the inequalities. So you will have the square number of x minus 3 is less than the square number of x plus 3. And then you can just simplify both sides of the inequalities. So you will have x squared minus 6x plus 9 is less than x squared plus 6x plus 9. Then you can just cross the same parts on both sides, x squared and 9. So you will have negative 6x less than 6x. And then you can just move the left side to the right. So you will have 0 is less than 12x and 0 is less than x. So this is actually the range of the value of x to this inequality. Please remember that when you want to use method 2, square both sides, to solve inequalities with absolute values questions, you must have absolute values on both sides of the inequalities. If you only have one side has absolute values, don't use this kind of method, since square both sides might change the range of the value of x. The third method to solve inequalities with absolute values is to transfer the absolute values into distance and the number line. For example, let's use the same examples as method 1 to explain it. If we have the absolute values of x minus 3 less than 7, so in method 1, we just take off the absolute value marks directly. But in method 3, we just transfer the absolute value of x minus 3 into the distance on the number line between point x and point 3. For example, let's just draw a number line here. So here is point 3 on the number line. What we're looking for are those x that has the distance less than 7 to the point 3. So how we find those points of x? First, we can just find out that those points who has the distance equals to 7 to point 3. So you can use 3 to plus 7 and minus 7 to get those 2 points, points 10 and point negative 4. These 2 points has the distance equals to 7 to point 3. And those points who has a distance less than 7 are those points between negative 4 to positive 10. So these points are the points we're looking for that has a distance less than 7 to point 3. So in this way, we also get the range of the value of x is negative 4 less than x less than 10. It's the same as we find out in method 1. So compared to method 1, method 3 makes the absolute values more visually. So I highly recommend that you can try this method out when you solve these kinds of questions. Okay, let's just use some data sufficient questions to have a deeper understanding of those methods we have just learned. So this question is asking for the value of the absolute value of x plus 7 plus the absolute value of x minus 5. As we have learned in method 3 that the absolute values can be seen as the distance between 2 points on the number line. So the absolute value of x plus 7 can be seen as the distance between point x and point negative 7. And also the absolute value of x minus 5 can be seen as the distance between point x and point 5. So let's just draw a number line here. First, we look for the point negative 7 and point 5. Where is x? We have to figure it out. If x is between negative 7 and 5, like here, no matter what's the value of x, you can say that the distance between x and negative 7 plus the distance from x to 5 will equals to the distance between negative 7 to 5. So it will equals to 12, right? But if x is greater than 5 or x is less than negative 7, the value of x will change the value of this equation. So let's just say statement 1. Statement 1 tells us that the square of x is less than 49. So x is greater than -7 and less than 7. So as we have discussed, that if x is between -7 and 5, no matter what's the value of x, these values will equals to 12. But under statement 1, there is another chance that x is greater than 5 but less than 7. So in this way, the value of x will change the value of this equation. It will greater than 12. So we cannot figure out the only one value of these equations under statement 1. So statement 1 is not sufficient. Statement 2. Statement 2 tells us that the square of x is greater than 25. So x is greater than 5 or x is less than -5. So if x is between -7 to -5, so this value will be equal to 12. But if x is greater than 5 in statement 2, the value of x will change the value of this equation. It will not equals to 12. So statement 2 is also not sufficient for us to figure out the only one value of this equation. Now we have to combine these two statements together. When we combine these two statements together, we will figure out the range of the value of x, that is, x is greater than 5 and less than 7, or x is greater than -7 and less than -5. If x belongs to this range, we can say that the value of this equation will equals to 12. But if x is in this range, greater than 5 but less than 7, the value of x will change the value of this equation. So when we combine these two statements together, we cannot figure out the only one value of this equation, so it is also not sufficient. So the official answer of this question is E. Okay, here's another example. In this inequality question, we have absolute value marks on both sides. So as we have learned before that if we have absolute value marks on both sides, we can square both sides to remove the absolute value marks. So let's try it together. So first you square the left side, so you will have the square of A minus B. And the right side, please be careful that when you square the right side, you can only remove the outer absolute value marks. So you have to keep the inner absolute values unchanged. So you will have like this. And then you can just simplify both sides. So you will have a squared plus b squared minus 2ab less than the square of absolute values of a plus the square of absolute values of b minus 2, like this. And then you can just take a look at both sides. The left side has the square of a and square of b, and the right side has square of absolute values of a and square of absolute values of b. And actually they are the same, so you can cross them together. So you only have the -2ab on the left, and you have -2 the absolute values of a and absolute value of b on the right. And then you can just divide it both sides by -2, and you will have the product of AB is greater than the product of the absolute value of A and B. As we have learned in the last lecture, that when we multiplied or divided both sides by negative numbers, the symbol here will change. So it changed from less than to greater than. So the question is actually transferred into this one. So you're looking for that the product of A and B is greater than the product of the absolute values of A and B. So let's just think about it. What's the value of A and B that can make these questions correct? Well, if A and B are both positive, the product of A and B is equal to the product of the absolute values of A and B. And if A and B are both negative, it is also equals to. But if one of them is positive and one of them is negative, the product of A and B will less than the product of the absolute value of A and B. So as we can see that under no circumstances these inequalities can be correct. So what that means? No matter what's the value of A and B, this question has the only answer. It is false. So in these questions, we don't have to take a look at statement 1 and statement 2. Since even we have statement 1, the product of A and B is less than 0, it cannot change the conclusion that this question is false. So statement 1 is sufficient, and also statement 2 is sufficient. So the official answers of this question is D. Okay, so the second kind of questions in our lecture is inequalities with square numbers. The first method to solve this kind of question is simplification. Actually, simplification method is quite useful not only to these kinds of questions, inequalities with square numbers, but also other kinds of inequality questions. So please remember to simplify both sides of your inequalities before you move on to statement 1 and statement 2. And we will have examples to have a deeper understanding of this method later. Well, the second method to solve these kinds of questions is you can just transfer the comparison of square numbers into the comparison of absolute values. As we have learned before that if we have the absolute values of A is greater than the absolute value of B, you can just square both sides. You will have A squared is greater than B squared. So actually you can say that the comparison of square numbers is actually the same as the comparison of absolute values in inequality questions. So when you have comparison of square numbers and you cannot figure it out how to solve these kinds of questions, you can also change back into the comparison of the absolute values. Okay, so let's use these examples to have a deeper understanding of the method we have just learned. Now, this question is asking for that whether the square of x is greater than the square of y. As we have learned before, that when we compare the square numbers, we can transfer it into the comparison of absolute values. So actually the question is asking for that whether the absolute value of x is greater than the absolute value of y. Okay, so let's just take a look at the statement 1. Statement 1 tells us that the absolute value of x is greater than y. But actually in statement 1, we cannot determine that y is positive or negative. For example, if y is positive, then y is equal to the absolute value of y. So in this way, we can get the absolute value of x is greater than the absolute value of y. But if y is negative, so y is less than the absolute value of y. So in this way, we cannot determine that whether the absolute value of x is greater than the absolute value of y. So statement 1 is not sufficient since we don't know whether y is positive or negative. Okay, statement 2. Statement 2 tells us that x is greater than the absolute value of y. So in this way, y must be positive since y is greater than a non-negative number. So x must be positive. So as we have learned that x is positive, so the absolute value of x will equal to x and then is greater than the absolute value of y. So in statement 2, we can determine that the absolute value of x must greater than the absolute value of y. So statement 2 is sufficient for us to determine that the square of x is greater than the square of y. So the official answer to this question is B. Okay, the third kind of questions in inequalities is inequalities with square roots. Please remember that these kinds of questions, you have to make the numbers under square roots non-negative numbers. For example, the first inequalities we have square root of x squared is less than the square root of 4. So x squared is less than 4 and also no less than 0. So what's the range of value of x is actually x is less than 2 and greater than negative 2. So this is the range of value of x to the first inequalities. And second inequalities, we have x under the square root. So x is less than 4, and also please don't remember that it is no less than 0. So this is actually the range of value of x to the second inequality. Okay, the last kind of question in inequalities is inequalities with exponential functions. I think this one is the most difficult one, but actually the method to solve these kinds of questions is quite simple. You can just draw the exponential function lines in one coordinate systems to solve these kinds of questions. For example, the question is asking for that whether x is greater than y, and statement 1 tells you that the negative x power of 5 is greater than negative y power of 3. Statement 1 gives you two exponential function lines. You can just draw them in one coordinate systems. But actually, please remember that here you have negative x power of 5, so you can just transfer it into x power of 1/5. Since x power of 1/5 is actually equal to negative x power of 5, so you can just transfer it into this one. And also, negative y power of 3 is actually equals to y power of 1/3. So actually, statement 1 can actually transfer into x power of 1/5 is greater than y power of 1/3. So you can just draw these two lines in one coordinate systems. Okay, here are two lines drawing one coordinate system. The purple one represents x power of 1/5, and the red one represents y power of 1/3. Can we use two lines to determine whether x is greater than y? Okay, in the first statement, statement 1 tells us that the value of the purple line's point is greater than the value of the red one's point. So let's just find a point on the purple one, point A here, and we draw a horizontal line across point A. And all the points on the red line under these horizontal lines satisfy the statement 1, right? Here, all the points here satisfy statement 1 since they're under the point A. But can we use statement 1 to determine that x is greater than y? No, we cannot determine it. Why? Because we can find 2 points, point B and point C. They are actually opposite examples to these questions. Let's just take a look at point B. Point B is on the left side of point A, which means that the power of B, yb, is less than the power of A, xa. But what about point C? Point C compared to point A. Point C is on the right side of point A, which means that the power of C, yc, is greater than the power of A, xa. So point B and point C are two different examples to this question, so we cannot determine whether x is greater than y. So statement 1 is not sufficient. Okay, statement 2. Statement 2 tells us that both x and y are negative, but there are no more informations for us to determine that who is greater, So statement 2 is not sufficient. And statement 1 and statement 2 combined together, like it is also actually the same as statement 1. Since statement 1, we found two different points, point B and point C compared to point A. These points are on quadrant 2. In quadrant 2, x and y are negative, so statement 1 and statement 2 together is also not sufficient. The reason is the same as statement 1. So the official answer to this question is E. This is all about inequalities part 2. We hope that these two lectures, Inequality Part 1 and Part 2, will help you to have a deeper understanding of this topic in GMAT test. You can find us on Facebook, GMAT770, and here is our email address for you to have any questions about GMAT test to ask. And in the next lecture, we will move on to the next topic. Hope to see you in the next lecture. Bye.